Good morning, students. In the previous class, we learned about the ingredients of the concrete like cement, aggregate, in that aggregate, fine aggregate, coarse aggregate, and also the water. So these are called as the ingredients of the concrete. So other than those ingredients, we can also add some admixture to the concrete to increase the properties of a concrete. The properties like a workability, strength, and also the setting time of the concrete. So to increase that properties, we are going to add some of the admixture for a concrete. So today's class we'll learn about what are the different type of admixtures we are added to the concrete to increase their workability and to their strength. So first we'll see what are the admixtures. Admixtures are the natural or manufactured chemicals which are added to the concrete before or during mixing. So whenever we are mixing the concrete ingredients, so as we know, concrete ingredients are cement, aggregate, and the water. Okay, that aggregate includes both fine aggregate and the coarse aggregate and water. So whenever we are mixing these ingredients, during that time also we are adding another ingredient called as a admixture. The most often used admixtures are air entraining agents, water reducers, water reducing retarders, and accelerators. Okay, so these are the type of admixtures and how they are going to work. What are the functions of these admixtures, that we'll see further. Why we use the admixtures? So before going to the type of admixtures, why we need to add the admixture in a concrete, that we'll see. Admixture are used to give a special properties to fresh or a hardened concrete. So if the fresh concrete is just a mixed concrete is called as a fresh concrete. Once it sets, then it is called as a hardened concrete. So to increase their properties of a fresh concrete and hardened concrete, we are using the admixtures. Admixtures may enhance the durability, workability, and the strength characteristics of a given concrete mixture. So it increases its durability, workability, and the strength of the concrete. Admixtures are used to overcome a difficult construction situations such as a hot or a cold weather placements, pumping requirements, early strength requirements, or very low water cement ratio specification. For example, in a pumping concrete, you have to pass the concrete in a pipes. So it should be in a plastic condition to pass it in a pumping constructions. So but the concrete has a special characteristics that after some times it is going to sets. So to prevent that setting time of a concrete or to increase the setting time of the concrete, we are going to add the admixtures so it remains in a plastic condition or mobile condition. So those are called as retarders. Okay, so whenever you want to place in a cold weather or if you want to use in a hot weather, then also we have to use some of the admixtures. And also to get the early strength, as we don't have much time for construction, we want to construct the building very fast, then also we need to set the concrete very fastly. So the fast setting will happens because of this admixtures. Okay, how to use these admixtures? These admixtures are used in appropriate quantity whenever we are mixing the concrete ingredients. So what is the quantity we have to use, that we are going to learn in the design of concrete mix design. So during that we'll see what is the quantity of admixture we have to add. Now we'll see what are the type of admixtures. So the first type of admixtures, there are two types. One is a chemical admixture, one is a mineral admixture. So we'll study first the chemical admixture. So the first type of chemical admixture is air entraining admixtures. So the air entraining admixtures are liquid chemicals added during the batching concrete to produce the microscopic air bubbles called as entrained air when a concrete is mixed. So to create air bubbles and to prevent the entry of air to the concrete, air entraining agents are used. So whenever you are using this air entraining agents, the microscopic air bubbles are going to occur. That air bubbles are going to entrap the air. So the atmospheric air will not enter into the concrete, hence the strength can be achieved. The good strength of a concrete can be achieved. These air bubbles improve the concrete resistance to damage caused by freezing and thawing and designing salt application. In plastic concrete, air improves the workability and may reduce the bleeding and segregation of a concrete. Also, this air entraining agents will also help for bleeding and segregation of concrete mixture. Bleeding is suppression. Okay, bleeding is the more quantity of water when when you add a more quantity of water, the concrete is a very mobile condition and it is like a very this liquid type condition, that is bleeding. So when the bleeding is increases, the particles will start segregate. So that is called bleeding. And segregation is separating of the particles will occur sometimes if the proper mix design is not done. So to avoid this, what we can add the air entraining agents. For exteriors, flat walk, parking lots, driveways, sidewalks and pool decks that is subjected to freezing and thawing weather cycles in areas where desired salts are used, specify a normal air content of 4 to 7% of the concrete volume depending upon the size of the coarse aggregate. So it is used about 4 to 7% of the concrete weight or a concrete volume. Whatever the weight of a concrete will get, of that 4 to 7% what we are using the air entraining agents, especially the concrete which are using in the parking lots, driveways, sidewalks. So this will subject to the continuously cold and hot weather conditions. During that we are adding the air entraining agents. Air entrainment is not necessary for interior structure concrete since it is not subject to freezing and thawing actions. It should be avoided for concrete flat work that will have a smooth traveled finish. In high cement content concretes, air entrainment will be reduced strength by about 5% for each 1% of air added. But in low cement concrete, adding air has a less effect and may even cause a modest increased strength due to the reduced water demand for required slump. Air entraining admixtures for use in concrete should be meet the requirements of ASTM C260. Okay, the specifications for air entraining agents means what are the characteristics of this air entraining agents which are using in a concrete should satisfy ASTM standards. Okay, ASTM standards, it should match it. Next type of admixture is water reducers. Water reducers are used for different purposes. First one is to lower the water's content in the plastic concrete and increases its strength. So as we know, when the water is more in a concrete, the strength is going to reduces. So we call it as a water cement ratio. The appropriate quantity of water is to be added to the concrete to achieve the proper strength. If the more the water content, then what happens? The strength is going to reduced. So that should not happen in a concrete. So to take the safety measures, what we are adding? Water reducers. They reduce the water content and increases the strength. This is the first objective. To obtain a higher slump without adding the water. So we are going to do the slump test. So to slump test is done to check the workability of a concrete. Depending upon the slump height, slump is a cone-like structure. So once the concrete is prepared, we are going to form one cone structure using the slump apparatus. So if the slump height is good, then we can call it as it is good workable concrete. So depending upon that slump height, we are deciding the slump value. If the slump value is good, then the workability of the concrete is good. So that we are going to study the slump test in the next highway and concrete lab. Okay. The water reducer will generally reduce the required water content of a concrete. Water reducer may aggregate the rate of slump loss with a time. Water reducers should meet the requirements of type of ASTM 494 specification for chemical admixtures of a concrete. Okay, this is ASTM standards has to match. Then next type of admixture is retarders. Retarders are the chemicals that delay the initial setting of a concrete by an hour or more. So The setting time of the concrete, as you know, when you use the concrete in fresh condition, after sometimes it is going to set very fastly. So this initial setting time of a concrete, when it sets very fastly during pumping construction, means you have to supply the concrete to the some area using the pumps. Okay, then what it should be? It should be a mobile in condition, or it should be a flowable in condition. So to make it more flowable, then what should not happen? It should not set fastly. If it sets, it hardens. So I don't want to hardens very fastly. So I want to prevent that hardening capacity of a concrete. I want to make it delay. The hardening time of a concrete, want to make it as a delay. So for that, what I should do is I should add the retarders. By adding the retarders, you can keep the concrete for a flowable condition or a mobile condition in a longer time. Retarders are often used in a hot weather to counter the rapid setting caused by the high temperatures. Yes, as we know, when a temperature increases, it sets very fastly. For a larger jobs or in a hot weather, specify concrete with a retarder to allow more time for placing and finishing. Most retarder also functions as a water reducers. Okay, as you know, it absorbs the water and reduces the setting time. So in sometimes what they have told that retarders will act as a water reducers also, and it should match the specification of ASTM C464. And next we have accelerators. Reduce the initial setting time of a concrete and giving high early strength. Accelerators, it accelerates the strength of a concrete. By adding the accelerator to the concrete, I can get the early strength of a concrete. Whatever the strength you are achieving in a 28 days, you can achieve in a 14 days by using the same materials, by using the accelerators. Okay, accelerators do not act as an antifreeze, rather than the speed of the setting and rate of strength gain, thereby making the concrete stronger to resist the damage from freezing in cold weather. Accelerators are also used in a fast track construction requiring the early from removal, opening to traffic or load application on structures. For example, you are going to construct some concrete roads. So I want to use that roads for frequently for movement of the goods and the passengers. So I wanted the roads should be free early. So but I want to achieve the same strength, because if you are not achieving the same good strength, then they will not durable for longer days. So I want to use it very early, that roads, then I can use the accelerators. These accelerators should specify their characteristics according to ASTM standards. Okay. A next type of chemical admixture is high range water reducers. Is a special class of water reducer often called as a super plasticizers. Yeah, these are called as a super plasticizers used for reduction of water content in a concrete. The high range water reducer reduces the water content of a given concrete mixture between 12 to 25%. So whatever the water is present in a cement, that will reduce by 12 to 25%. Hence, the high range water reducer used in increased strength and reduces the permeability of a concrete by reducing the water content in the mixture, or greatly increases the slump and produces a flowing concrete without adding the water. These admixtures are essential for high strength and high performance concrete that contain a higher content of cementitious material and mixture containing a silica fume. Okay, the high range water reducers or super plasticizers are used where the concrete of a good strength we want to achieve. There we can use the super plasticizers. This will reduce the water content and increases the strength. Okay, so in the this PDF you can see the recommended air content in a concrete. So to use this air entering agents, you have to go through this. Okay, so go through this table, what it is there, and check it out. So these are all called as a chemical admixtures. Okay, So these are artificially prepared and manufactured in the laboratory, then it is given to the market, and so hence it is called as a chemical admixture. Next we have another type of admixtures called as a mineral admixtures. So there are two types of mineral admixtures. One is having a cementitious properties, one is having a pozzolanic properties. So we'll see what are the cementitious properties and what are the pozzolanic properties. The cementitious properties of mineral admixtures will have a property same as a cement. So we all learned about the cement composition, right? The cement composition of silica, calcium, magnesium, right? These are all the composition of the cement. Same way these admixtures will also same properties. Okay, so example for the cementitious admixtures are ground granulated furnace slag. It is also called as GGBS, GGBFS. So I'll explain what is GGBS in the next part. This is called cementitious mineral admixtures. Okay, these are the admixtures which are having the properties same as a cement. And next we have a pozzolanic mineral admixtures. What is this pozzolanic mineral admixtures? A pozzolana is a material which when combined with a calcium hydroxide exhibits the cementitious properties. Okay, so the pozzolanic properties is what? Any material. Okay, you take any material. For example, I'll take the fly ash or a silica or a rice husk ash. So you take that material mixed with a lime. Okay, that will exhibit the cementitious properties. Cementitious properties like the properties same as the cement. Okay, so the pozzolana are commonly used as an addition to Portland cement to increase the long-term strength and other material properties of a Portland cement concrete. Yeah, nowadays this is very trendy use of this pozzolanic material, because when you use this pozzolana material, the concrete gives the better strength comparing to Portland cement or the Portland concrete. So what are those pozzolana material? Fly ash, silica fume, rice husk ash and metakaolin. So remember, four type of mineral admixtures. Two types of mineral admixtures. In that, one is cementitious and second one is pozzolanic. And that cementitious is GGBS and pozzolanic is fly ash, silica fume, rice husk ash and metakaolin. So first, the pozzolanic action. Where the materials, the pozzolanic materials are used. It is used as a filler, nucleating and a pozzolanic material. So filler means these additives or admixtures are finer than a cement. So when added to the concrete, they occupy the small pores previously left vacant. Okay, when you use this fly ash or a silica fume, it will not give any of the vacancies or any of the pores. So when the voids or the pores are less, the concrete is going to achieve a good strength. Hence, this fly ash or silica fume or rice husk ash or metakaolin can be used as a filler. And next is nucleating. It is used as a nucleating. These fine particles accelerate the rate of hydration and precipitation starts. So the pozzolanic materials are used as a nucleating materials. The fine particles of this fly ash or silica will accelerate the rate of hydration. When the rate of hydration increases, it achieves the good strength. So that is achieved by this pozzolanic material. And next is pozzolanic action. What is this pozzolanic action? When cementing material react with the water, the following reaction will take place, as we already learnt in a Box compound. Okay, so C2S, okay, dicalcium silicate, when mixed with this HCH and CH, the CSH is responsible for strength, while CH is soluble material reacts and dissolves in a water, leaving behind pores. So by adding this, the CSH is a responsible for strength. So by adding this pozzolanic material, it increases the strength, that it increases the CSH properties. Hence, this pozzolanic material is added. So in that, the mineral admixture is GGBS. What is this GGBS? Ground granulated blast furnace slag is the granular material obtained from when molten iron is blast furnace slag is rapidly chilled by immersion in water. It is a granular product, highly cementitious in nature, and ground to cement fineness, hydrates like a Portland cement. So when iron production is occurring, so we want iron for various purposes. When a manufacturing iron is done in a furnace is a chamber where the high temperature is given to the material. So when the manufacturing of the cement, the waste material is left out at the bottom of this furnace or a chamber. That waste material is called as a ground granulated blast furnace slag. We say it as a byproduct of steel manufacture. It's a byproduct of iron manufacture or a steel manufacture, which is sometimes used as a substitute for Portland cement. So it can be used as a replacement, partial replacement. Whenever you are using the Portland cement, in a place some amount of this Portland cement is replaced with this GGBS. GGBS is used to make a durable concrete structure in combination with a ordinary Portland cement or other pozzolanic materials. The GGBS has been widely used in Europe and increasingly in the United States and in Asian countries for its superiority in concrete durability, extending lifespan of buildings from 50 years to 100 years. So when you add the GGBFS with Portland cement, the durability of a concrete is going to increases. Concrete made with a GGBS cement sets more slowly than a concrete made with ordinary Portland cement, depending upon the amount of GGBS in the cementitious material, but also continues to gain a strength over a longer period in a production of conditions. As the days goes, this GGBS concrete mixed with a Portland cement will achieve a good strength comparing to the normal Portland cement. Use of GGBS significantly reduces the risk of damages caused by alkali silica reactions, provides a higher resistance to chloride ingress, reducing the risk of reinforcement to corrosion, and provides higher resistance to attack by sulfate and other chemicals. So these are the merits of GGBS or advantages of GGBS using in a concrete with Portland cement. So this is asked in short note. Write about GGBS. So you should write what is the GGBS, where it is used, and what are the advantages. Okay. So benefits is given. Durability. Cement is routinely specified in a concrete, provide the protection against both sulfate attack and chloride attack. GGBSFS is also routinely used to limit the temperature rise in a large concrete pores. Appearance. In contrast to the stony grey of concrete made with a Portland cement, the near white color of GGBS cement permits the architect to achieve a lighter color for exposed fair-faced concrete finishes with no extra cost, and good strength and ultimate strength can be achieved with this GGBS. Okay. And next is fly ash. So what is a fly ash? Fly ash is a residue or a waste resulting from the combustion of ground or powdered coal. I think you've all known the coal, where the nuclear power plant we are using the coal. So when you burn the coal, there is some ash is left out. That ash is called as a fly ash. This fly ash is generally captured from chimneys of coal-fired power plants. It has a pozzolanic properties, and it's sometimes blended with cement for this reason. It's having a good pozzolanic properties. Okay, hence this is used with a ordinary Portland cement. Okay, fly ash includes the amount of silica and calcium oxide. So we know properties of cement. It includes the SiO2 and CaO. Same property it is also having. Okay. So there are types of fly ash are there. One is class F fly ash, class C fly ash. We'll see what are those fly ash and which is used in concrete. The burning of harder, older anthracite and bituminous coal typically produces a class F fly ash. Okay. Anthracite and bituminous coal. When you burnt anthracite coal or when you burnt this bituminous coal, it produces a class F fly ash. This fly ash is pozzolanic in nature and contains less than 10% of lime. The glassy silica and alumina of class F fly ash requires a cementing agent such as a Portland cement, quicklime or hydrated lime with the presence of water in order to react and produce the cementitious compounds. So the class F we obtained from anthracite and bituminous. Then the class C, it is obtained from burning of younger lignite coal or subbituminous coal. Okay, it is obtained from lignite coal or subbituminous coal. In addition to having pozzolanic properties, also have some self-cementing properties. In the presence of water, the class C fly ash will harden and gain a strength over time. Class C fly ash was generally contains more than 20% of lime. Unlike class F, self-cementing class C fly ash does not require an activator. Alkali and sulfate content are generally higher in class C fly ashes. In addition to economic and ecological benefits, the use of fly ash in concrete improves the workability, reduces the segregation, bleeding, heat evaluation, permeability, and inhibits the alkali aggregate reaction and enhances the sulfate resistance. From the past 20 years, it is most common. We are not using only Portland cement in a concrete. We are replacing the some amount of cement with a fly ash. Okay, as we know, the concrete ingredient are cements and aggregates. So this cement, if you got in a mixed design, if you get about 20 kg of a cement, then 10 kg of the fly ash is used and 10 kg of the Portland cement is used. Like based upon the construction purpose, what is the percentage of the fly ash to be added will be decided. Okay, the addition of this fly ash is becoming more common because it is having the same characteristics as of a cement. Next one, we'll see another type of a mineral admixture is silica fume. This is a byproduct of semiconductor industry. The terms condensed silica fume, microsilica or silica fume and volatile silica are often used to describe the byproduct extracted from exhaust gases of silicon, ferrosilicon and other metal alloy furnaces. So whenever you are manufacturing some semiconductor materials like diode, okay, some electronic materials, then the left out waste, whatever will left out in a furnace, that is called as a silica fume. That silica fume is using as a replacement for a cement. Silica fume was first obtained in Norway in 1947 when environmental restraint made in the filtering of the exhaust gases from the furnace compulsory. Silica fume consists of a very fine particles with a surface area ranging from 60,000 to 1,50,000 feet square per pound or 13,000 to 30,000 meters square per kg, with the particles approximately 100 times smaller than the average cement particle. Because of its extreme fineness and high silica content, silica fume can effectively used as a pozzolanic material. Silica fume used in a concrete improves its properties. It has been found that silica fume improves the compressive strength, bond strength, abrasion resistance, reduces permeability of concrete to chloride ions and therefore helps in protecting reinforcing steel from corrosion, especially in chloride rich environments such as coastal regions. Okay, so what are the characteristics of the silica fume to be used as a cement in a concrete? Because it is having a high silica content. When the silica content is high, Then it increases the compressive strength, bond strength, abrasion resistance, and mainly the chloride and sulfide resistance in the coastal zones. Hence it can easily used as a mineral admixture in a concrete. And last one of the mineral admixture is rice husk ash. This is a bio waste from the husk left out from the grain of rice. So we all know the rice, how the rice is obtained. Rice is obtained from paddy leaves. Okay, once the paddy is cut and the paddy's cover is removed, we'll extract the rice. So whatever the rice cover is left out, that rice cover is called as a rice husk ash. Okay, rice husk, that is called as a rice husk. So when you burn that, then ash is obtained, then it is called as a rice husk ash. So the paddy waste, or it is a waste obtained from the grains of rice, hence it is also called as a bio waste. It is used as a pozzolanic material in a cement to increase the durability and the strength. The silica is observed from the ground and gathered in the husk, where it makes the structure and it is filled with a cellulose. When a cellulose is burned, only silica is left out, which is grinded to fine powder, which is used as a pozzolana. So when you burn this paddy waste, then that ash will contain a more content of a silica. That silica can be used as a pozzolanic material for a concrete. Hence this rice husk can also be used as a mineral admixture. So remember, the mineral admixtures are two types. One is a cementitious, another one is a pozzolanic type. In cementitious mineral admixture, I have one. In pozzolanic mineral admixtures, we have 4 types. So what is this cementitious example is ground granulated blast furnace is a cementitious material, and mineral admixture is a fly ash, silica fume, and a rice husk ash. Okay, so you got to know what is GGBS, fly ash, silica fume, and rice husk ash. Okay, these are all the byproduct of some material. Okay, that byproduct are generating in the environment in a huge quantity. So there is a problem with the disposal of these materials. So to prevent that disposal problems, what they have done, they have used in a concrete. Okay, they are reusing those material because we are facing the land scarcity for their disposals. So instead of disposing them on a land, they are reusing in a concrete. When you reuse it in a concrete, they are increasing the concrete properties, hence it is becoming a useful. Okay, so students, all of you go through this admixtures topic, and if you have any doubt, you can ask me at any time. Okay, thank you all of you.